This is Unit 4, Review 2. This is number 3. This is the problem where they give you all the information so you don't have to find it. All right, you're going to take that information and you're going to put it onto the grid. So I have a grid here. All right, you plot all the points. So that's the negative 12, negative 5, negative 11, negative 3, negative 8, 1, negative 5, negative 5, negative 2, negative 9, 4, 5. And then it says at f of 2, it's undefined. That's where you have your vertical asymptote. So you can see your vertical asymptote right there. All right, whenever you have an undefined, that's going to be the vertical asymptote. If you look down at the bottom of what the information I give you, it says that it's approaching 2 from the left side is going to be going to infinity, and 2 from the right side is going to infinity. So that means on either side of that vertical asymptote, the graph is going up to positive infinity. And then the other two pieces down there for the limits, it's negative infinity and positive infinity. So as x goes to negative infinity, that's your far left, it's going to be getting closer and closer to negative 7. So this is 2, 4, 6, negative 7. So that's going to be a horizontal asymptote out over on the left side. All right, likewise, when it's talking about the limit as x approaches infinity, that's the far right. It's going to be getting closer and closer to 3. So here's 3 out here on the far right side. All right, typically what I do next is go through and find my points of inflection. My points of inflection are where the second derivative is set equal to 0. So that's that negative 11 and negative 5. So here's negative 11, and I normally indicate that with a star, and there's negative 5. All right, it then tells you that the derivative is equal to 0 at negative 8 and negative 2. So negative 8, you see this right over here, that means that's going to be a minimum or a maximum. Looks like it's probably going to be a maximum right there. Excuse me, and then at negative 2, looks like this is probably going to be a minimum right there. All right, so just kind of keep that tucked in the back of your mind there for those two. So this point over here, and this point over here, we really didn't know anything about. They're probably just going to be like guide points as we go through. All right, I typically like to draw in my guidelines, and I get this from my first derivative. First derivative is positive from negative infinity to negative 8. That means it's going to be increasing here. So we normally draw these guidelines in. It tells you the general path of what this graph is going to look like. And then it's also increasing from negative 2 to 2. So negative 2 to 2, this is also going to be going up, which means it's decreasing the rest of the way. Negative 8 to negative 2, so it's coming down. Excuse me, and then from 2 to infinity, it is increasing. Or it is decreasing, I'm sorry, I said that wrong. So from 2 to infinity, it's when it is less than 0, it is going to be decreasing here. So again, we're flipping. All right, it says when the first derivative is less than 0, that is when it is going to be decreasing. So the negative 8 to negative 2, that's this section in the middle. And over here from 2 to infinity. All right, so you can kind of see the ebb and flow of what the graph is going to look like. All right, we can always go to your concavity. That's when the second derivative is greater than 0, it's going to be concave up. Second derivative is less than 0, it's concave down. It looks like it's only concave down here in one spot, from negative 11 to negative 5. So negative 11 starts right here. All right, it's going to go to my negative 5. So there's my concave down, and that does make sense if that's going to be a maximum. From there, then, it's going to have to flip. So it's going to be concave up at the star on the left side, pass through this point. Remember, we have the horizontal asymptote on the left side there, so it's going to just stay right above that as you continue to go. All right, going on the right side now of this concave down section we just did is going to be now concave up, again coming down, bouncing at that minimum there, and coming up. And remember, we're going up all the way to the left side of that vertical asymptote. Last, we have the right side of the vertical asymptote. It's got to meet up here, and we know it's horizontal asymptote for a reason. It's concave up, so it's going to come down, pass through that point, go out over here to the left, getting closer and closer to the asymptote, but never actually touching it because you can never touch that asymptote.